All right, so how would you go about starting this question? Yeah.
So you would times 107, times it by 2, because that will get you A plus 92.
Okay, so you're looking at.
Yeah.
Let me get a different marker here. So you're saying you're going to take that angle 107.
Yep.
Okay.
It times by 2.
Okay, so let me write this down. So you're saying, because I want to stay consistent with the formula we talked about.
Yep.
So 107, an inscribed angle, is going to be half of the intercepted arc. And you're saying that intercepted arc is 92 plus A, right?
Yep.
Okay, so then you said you doubled it.
Yep.
So you got your 214 is equal to 92 plus A, right?
Yep. And then you subtract the 92 over to the 214.
Okay, so 214 minus 92 is 122.
Yep. So then A equals 1.
Would you guys agree that that subtraction is kind of hard? Like just without using a calculator, like right off the top of your head, can you do that quickly?
No.
Okay, but can you subtract 100?
Yeah.
What's 214 minus 100?
1.
114. But then what do I need to do with that 114?
Add 8.
Add that 8 back in. Is 114 plus 8 pretty easy to do?
Yep.
Yeah. Okay.
Okay.
So you got A. Now what?
Okay, so then you need you have to find C to find D. So you do 97 minus 180.
Okay, so you're saying that this angle here
Yep. It's
and this angle here are supplementary.
Yes.
Okay, and I heard somebody say that they did this first. They worked on the inside first. That's fine. The order of these two calculations is independent of one another. What's that mean? It doesn't matter. Order doesn't matter here. Okay. So what is angle C angle C's measurement going to be?
83.
83. Okay.
And then you gotta do then you gotta times 83 by 2.
Okay. So you're going to then, when you say multiply 83 by 2, you're telling me that you're looking at that angle of 83, and it relates to that intercepted arc, right? So you're going to say 83 is equal to 1/2 of 122 plus B, right?
Yep.
So multiply both sides by 2, so that gives you 166 is equal to 122 plus B.
Yep. Then you subtract 23 on both sides.
So B is 44 degrees.
Yep. And
Okay.
then you go to find D, you need to do 107 minus 1.
Okay. So then you're saying that that angle and that angle should be supplementary. So you're saying that angle D should be 73 degrees. I kind of work. Now, I'm not saying that's the only way. Okay, we said that we could have worked. You found D and C first, and then now you have all those inscribed angles. You should be able to work your way out to the intercepted arcs. Or you can kind of go back and forth like we kind of did there. How can I check myself? There in this particular problem, there's a built-in check. Cameron?
You do, well, to find the, try to see if the inside of those are correct, add 107, 97, 73, and 83.
Okay, that's good. So he's saying, C and D, those were found based off of opposite angles, right? Okay, being supplementary. So he's saying add those together. That was 83, and that was 73. So add those four angles together and gives you 180, right? Or sorry, it gives me 360, right? And that is true. So that tells me C and D were right.
And if you want to find A, B, 92, and the other one, you have to do 97 times 2 and subtract 92.
Okay, so I think you're stating something that I kind of want to talk about here. If I've got, and this I think is a good check because it incorporates a lot of the values, a lot of the things that we've done here. If I look at that arc, and that arc, can I add those together?
Yes. And then you need that arc.
And then how much more, or what is the relationship between all four of those arcs?
They equal 360.
They equal 360. So if I've got three of them, okay, so if I've got 360 minus the 92, minus the 122, minus the 44, does that give me this arc up here to be 102 degrees?
Yes.
Now, why would I want to do that? Yeah, if I look at this angle here, shouldn't that angle be half of whatever that arc is? And that arc is 146, right? What's half of 146? That's 73, right? So you see how that I used the number that we didn't have, 102, that we didn't need in the question, but then incorporated 44, which was B. It incorporates D, okay? And I'm using multiple values that I had to find, and I'm developing a relationship that I now know to be true using those things, and using 102, which is a number that we didn't need. And I developed that 73, which we knew was a number that developed throughout the problem, right? So it's kind of reassurance through use of multiple things in this problem that we've got arcs and angles correct here, okay? Or if I just look at the interior and the inscribed angles adding up to 360, I don't know if that's going to validate the arcs as much as it just validates the angles. Does that make sense? Okay. But I think either approach is something to look at. Okay. But there are multiple ways to check things, and that's something as you guys are going to find out as you move through other courses. We finish this course up. When people say, what's the check for this problem? Because the approach for the problems are all different and vary from, I can give you, 3 or 4 more problems that are very similar to this, but the process that you go through is different. The checks for those might be different. Does that make sense? Okay. But you can mess around with the values that you find, the values that you start with, and see if you can replicate any other values that are in that problem. If you can do that, then chances are the math that you've done and the numbers you've come up with are right. Okay. I think you start to build a much better understanding of mathematics and the system of mathematics if you force yourself to work through checks. This one here, we talked about it in the last class, and what I want you guys to try to avoid doing is trying to say, okay, well, A is alphabetical first, so I'm going to try to solve for A first, okay? And you can actually do that here. You can solve for A first, but I don't want you to get in that habit, because when I create a question, what I do is I kind of work with the picture overall with all the answers in it, and then I start scratching the numbers away, and I just put like R, and then I'll scratch away this number, and I'll put W, and then I'll scratch away this number, and I'll put A, okay? And the way that I did that was just arbitrary, so I don't know if you can find A first. Does that make sense? Okay? And that's kind of how maybe the end of course exam is going to be written. You don't, just because things are alphabetical doesn't mean you can always solve for X first before you solve for Y. And I've seen people sit on tests and spend 2 minutes, 3 minutes, 4 minutes, 5 minutes trying to solve for that first variable because it's alphabetical, and you're just spinning your wheels because you can't. You have to solve for the other one first. Does that kind of make sense? When you see problems like this, my suggestion is just start somewhere. Start somewhere where you know a true fact, and then start moving from there. Okay. So what is actually, I'm gonna kind of dictate this. Maybe you didn't do it this way, and we'll talk about maybe a different method. But I see right away, because I think it's the easiest relationship that we have. I see right away that this arc here, do you guys agree that's attached to that central angle? So does that make that 56? Now, this is another kind of thing about these types of questions. In geometry questions, trigonometry questions, calculus questions, is that there's no variable here, right? They're not asking about that angle, but I might need it to progress to other places in the problem, right? Okay, so that's 56. What would the relationship between that 56 and that angle right there be? Supplementary, okay? So that angle, even though they don't ask me for it, and if you didn't use this approach, that's fine. There are other ways, but that's 124, right? Now, why would that be beneficial? Would you agree that that 124 is a central angle? Does that make sense? Does that tell you what this arc here is? What's that arc there? 124. Now, they don't ask for that arc, but I do need that because isn't that arc intercepted by an angle created by a chord and a tangent? And what's the relationship between angle B and that 124? Yeah, B is half that, right? So B has got to be, what, 62? Okay. Now I see a couple things here that we could address A with. Let's use this relationship here first. What is that segment for the circle? A radius, right? And the directions of this question say lines that look like tangent are tangent. What kind of angle do we have between those red lines? 90-degree angle. If you know 62 of it, what's A? 28, right? Okay. Now, let's keep working at or looking at A. What's that for my circle? A radius. What's that for my circle? A radius. Is that an isosceles triangle right there? If I take 124 minus 180, or sorry, 180 minus 124, do I get 56 for that angle and that angle added together? And they both need to be the same, right? So does 56 divided by 2 give me 28? So there's multiple approaches that you can use to find that angle A. Okay? Now, what about C here? 84 divided by 2 is 42, right? Okay. Maybe a check here that exists. What would that angle right there be? That was 42 here. What would that red angle be? 70. Is that red angle intercepting this arc out here? What's that arc out there? 140, right? 70, half of 140. And that's the relationship we know should exist, right? Some of you might have said, well, I didn't do it that way. Maybe you, instead of going to, I started there and went straight to that angle, right? Anybody say, well, that 56 is attached to that inscribed angle A right there? Took half of 56, get you 28 that way, right? It's a third way that we found 28. Okay? And that's going to happen with these types of questions, is that there's going to be multiple ways of answering a particular measurement. Okay? Yeah. Maybe some of you said, what is that segment for my or for my circle? Diameter. So how many degrees is this arc here? 180, right? You already know 56 of it. So make that 124. Okay. Just as you kind of look at more and more problems like this and more problems in regards to just geometry in general, the number one statement that I get from students is just show me how to do it. Well, I don't know that I can. Okay. I can give you ideas on how to start. Okay. But there might be 10, 15 different ways to do it. Does that make sense? Okay. And depending on, obviously the more facts that you know, the more properties, postulates, theorems, and that kind of stuff, the more efficient and the quicker you can go through the problems. Okay. But math in general, there is not necessarily one way of always doing something. Okay. Let's look at the next section.